Testing.
Hello. Is Henri here? Oh, okay. Yes, I saw him. Hello, Henri. Henri.
Hello, nice to meet you.
Cool. Just catching time. Cool. So I guess we can start. Yeah. Hello, everybody. This is Tracy, the TinTinLand community manager, and welcome everyone to join our workshop today. And this presentation will go through what problem Starkware solves and how it works from a high-level perspective and how people can start to building stuff on it. The workshop will be around an hour, including presentation and a Q&A session. So let's welcome our guest, the Starkware Developer Advocate Lead, Mr. Henri Lieutaud, to start the presentation. Hello, Henri. You can.
Hey, hi, nice to meet you. Should I start presenting now? I see on the planning that I'm supposed to start in 40 minutes.
No, you can start from now. It's technically 4 p.m. in Anshin, so.
No, sure. What I mean is that on the display here, it's written 4:40.
Oh no, it's
no,
since actually after 40 minutes, supposed to be 20 minutes Q&A session, so that's the time to start it. Yes.
No problem. Okay, so let me pull up my presentation, and I'll be here in a second. So can I ask how many people are with us today?
From my side, well, right now, because we are streaming this on YouTube, so I have to ask my coworker to tell me exactly the number. Okay, I will tell later, I guess.
Wonderful. Okay, give me a sec. Beep, beep. And all right. Almost there. And now I'm presenting my screen. You should see my screen. Is that correct?
Yep.
Wonderful. All right, let's go. So, hello everyone. My name is Henri Lieutaud, or Henry. And today I'll try to explain what is StarkNet, what is Cairo, and how it can help scale blockchains first, and then scale the internet globally in the second phase. So my name is Henri Lieutaud. I'm based in Paris. I'm the lead developer advocate for StarkNet. So my job is to explain to people what StarkNet is and how they can build cool stuff on top of it. So for my presentation today, I chose to talk about StarkNet from first principle to give you an idea of what problems this solves and how you can get started with it. So let's start first with a step back. I know most of you here are Rust developers. I hope some of you are familiar with what blockchains are, but let's take a look at how blockchains works from a high level point of view and why they can't really scale, right? Which is an interesting thing, right? Blockchains are supposed to revolutionize the transfer of value. Both these technologies are less than 15 years old, and yet none of them has managed to scale to millions or billions of users. I know a lot of our audience is Chinese. You use WeChat or Alipay to pay every day. How come Bitcoin and Ethereum that are using much more recent technology are not able to accommodate this kind of scale? And at the end of the day, it comes down to the trust model that your network uses. In the old world, in the legacy world, you're using a trusted party to operate your financial backend. When you're using Alipay, you have a central company, Alibaba, processing the payment of everyone. And that allows them to be very efficient. It allows them, when there's a high demand, to spin up more machines and process everything for a big data center. And so it allows them to basically scale up, right? You throw more machines at the problem, and it works pretty well. In the blockchain world, people do it differently. The objective is to not rely on trusted party for a variety of reasons, and I'm not going to get into why blockchains are interesting, but you should understand that the trust model is different. Instead of trusting one party to operate the network, you want everybody to be operators in the network. And why? The main reason for that is that you want everybody to make sure that all the calculations are done correctly. And the only way to do that is to have everyone rerun the same computation over and over again until they are sure that, yes, we did have the same result. So this brings a lot of advantages in terms of trust, but it has a few drawbacks too. The biggest one are that you're sacrificing privacy and scalability. Privacy, because if you have to redo all the transactions of everyone, then you know what your neighbor has been doing and your neighbor knows what you've been doing, which is not ideal. The second thing you're sacrificing is scalability. If you want every participant in the network to validate what everybody else is doing, it means that the workload we were discussing earlier with billions of users, you have to be able to do them in your own. And that sounds very unlikely, right? Not a lot of people have the capacity to run the workload that Alipay runs every day to process transactions. So these networks are inherently limited by this. The more capacity you want to add, the less participants can participate, and the less interesting the network is. So there's an inherent tension between how much load the network can process and how many participants it will get. And here also you have another idea of why these transactions are slow and expensive. If one transaction, as a rule of thumb, if something is done by one person, one piece of work is done by one person, or is done by 10,000 people, then the piece of work that is done, same piece of work by 10,000 people, will be more expensive than a piece of work that is done by only one people, because you have to pay for all of these people, right? So this is why blockchains are slow and expensive. Now, in order to explain how to, that's the blockchain dilemma, right? That's the reason blockchains can't scale today. Now, I'd like to explain, in a nutshell, a new primitive, a new cryptographic primitive, and that is called validity proofs. And you should put validity proofs in your mind, in your programming toolkit, in the same category as where you put hashing functions or where you put digital signatures. They are a mathematical tool backed by pure mathematics. It's not something that has game theory. It's not something that has trust assumptions. It's something that is entirely mathematical. And you can dive into the theory of how this works, and I'll be happy to provide you guidance to understand how validity proofs work. But in your workflow as a dev, you don't necessarily have to, you just have to understand how they work. I mean, you have to understand how you can use them in your application. And here's how they work. Validity proofs. Oh, I think there's a small echo. Is it just on my side or now it's better? Perfect, thank you. All right, so what are validity proofs? Validity proofs are a way for a person, let's call her Alice, to execute a program. And once she executed her program, generate both the output of the program and a proof that she executed the program correctly. She's able to send the program, the output, and the proof to a second person called Bob, who is the verifier. And Bob will use the proof, put it in a special tool called the verifier, and he will get a feedback as to yes or no, did Alice execute the program correctly, without him himself executing the program. So to reiterate, it allows Alice to execute a program and prove to Bob mathematically that she executed the program correctly without Bob executing the program himself. And here, this is a fundamental paradigm shift in how computing works, because if I want you to be able to use the output of a program without having to trust me, up until now, the only possibility you had was for you to rerun the program. Now you have a new paradigm where I can run the program and you can use the output of that program without trusting me. Now, the really cool stuff about this is not only that it scales, is not only that you get to have a person who verifies the program and a person who executes it. There is also an asymmetry in the amount of resources that it takes to generate the proof and the amount of efforts it takes to verify the proof. Meaning, when Alice generates a proof for a computation, it takes less effort to Bob to verify the proof and be able to use the result than to execute the program itself. And even better than that, the bigger the program of Alice, the bigger the verifying part, but it scales logarithmically with the amount of computation that is done on the proving side. Meaning, the bigger the job done by Alice, the easier per unit of work it is for Bob to verify. So this allows, for example, a simple retail computer to use the output of a program executed on a supercalculator without having to trust it. That is a really nice property of these validity proofs. A simple heuristic can be that validity proofs are to computation what compression and a zip is to a file, the size of a file, right? It allows you to have a computer execute a program and somebody else use the output without having to run that program. So this is an extremely important primitive and an extremely useful one. Okay, I hope that makes sense so far. And now I want to explain a little bit how this works in the context of StarkNet and in the context of ZK rollups. Let me stop pause my screen sharing for a second. Up. The presentation I have now is nice, but there's another one I want to share with you. All right. I have those 3 slides that I like. Let me just Let me just pull this. I'll be here in a second. And there we are. Okay. Oops. Okay, we're back now. Right, we were here. Now I want to explain a little bit what it is we do at Starkware and what are the products we build. So let's explain the difference between Starkware, StarkX, and StarkNet, which you might have heard of. So Starkware is the company who is building tools leveraging validity proofs in the blockchain world. The company was founded by the people who invented validity proofs, or at least a specific kind of validity proofs. We are more than 100 people, and we raised a bunch of funds, so we're a strong company, and the tools we build are reliable. We currently have two products we used in order to scale blockchains. The first one is called StarkX, and StarkX is, in a nutshell, a white label trading engine. It allows you to run a trading platform with validity proofs, and I'll get into this in a moment. And the second product we're developing, which we're in the process of decentralizing, is StarkNet. So StarkNet is a ZK rollup on top of Ethereum. So how does StarkNet work? Well, you remember the slide I presented in the beginning where I explained how how blockchains work and why they don't work. Well, in the case of StarkNet, things work a bit differently than in a general purpose blockchain network. Using validity proofs, we now have the possibility to have a central operator or a few selected one, or not many operators, who can run their own data center or their own hardware and will be able to operate a network with high capacity. So this means that compared to a blockchain network where everybody validates the whole network on a retail computer, you can operate a network with much higher load because the operators are using much bigger machine. But every action that happens on the network is then proven to be correct, meaning the operators don't have the possibility to do anything else than what the users initially wanted them to do. So now you introduce an asymmetry between the operators and the users, so that the users can delegate work to operators without having to trust them. So we have here the sequencer, which is operating an OS, operating StarkNet. So StarkNet is a blockchain like, say, Ethereum. It has blocks, it has transactions, it has smart contracts, and it has an OS. And that OS is provable. So the sequencer will run that OS that will process blocks, and there's no way for it to run the OS in an incorrect manner. And every once in a while, after a few blocks, it will generate a proof that it operated the network in a correct manner. That proof is then, and it will generate the proof using the prover, which we call sharp. That proof is once in a while sent to Ethereum on a smart contract. And there is a smart contract on Ethereum that runs a verifier, a proof verifier. So that smart contract will basically take the proof that is generated by the sequencer and say, okay, the OS was run correctly and no shenanigans were done. No funds were stolen, all the smart contracts were executed properly, all the transactions were valid. This represents a correct execution of the network. So this allows the network to scale very nicely, because now you have service providers who will provide computing capacity, sequencers, and all of this verification is happening on a neutral substrate, which is Ethereum. And yeah, that's in a nutshell, that's how Starknet works, right? It's a blockchain that gets proven every once in a while, and on Ethereum, and then you can use it to do whatever you want. Now, one thing I didn't mention about Starknet, and one of the reasons why we're talking today, is that in order to write smart contracts on Starknet, you have to write them using a smart contract language, or that is called Cairo. And Cairo it's a general purpose programming language that is very Rust-like. It looks like Rust, and it has a lot of, it was modeled after Rust. This funny tweak here is that Cairo is provable, meaning you run it as you would run a Rust program, but every time you run a program, you can generate a proof that you run your program correctly. It's something you can do outside the blockchain. You can run a general purpose program written in Cairo, or you can write and the Starknet OS of the blockchain Starknet is written in Cairo and is provable. But it's also something you can use to write smart contracts on Starknet. So the Starknet OS runs subroutines written in Cairo that are also provable. All right, so in a nutshell, that's how Starknet works. I hope this makes sense. Please let me know if there are any questions. Now, I want to share a little bit why there is so much excitement about ZK rollup. So this is something that is maybe a bit more blockchain centric. I don't know how many of you are familiar with blockchains or what I will talk about. So I will go into this a bit quickly, and then we can do Q&A. So the first reason why people get excited about ZK rollups and Starknet in particular is cheap computation. Oh, give me a sec. So what do I mean by cheap computation? If you already wrote a smart contract in a blockchain network, you know that these are very constrained programming environments. You can't have a lot of variables, and all of those variables have a cost associated to them. So running complex program will very quickly be very expensive. To me, blockchains are kind of like programming on embedded circuits like Arduinos. They're fun to use, but you have to be very mindful of the space, the footprint of your program, of what it is. And if you add more computing power, then you could do a lot more. Well, with validity rollups, the size of your program is less a constraint than in a traditional blockchain network. The amount of compute is less constrained because you don't ask retail users to run your program, you ask specialized users to run your program. And these specialized users have the possibility to use bigger machine or use more machine to provide more computing power to the network. And therefore, they're able to lower the cost of executing code on these blockchains. So now you can do smart contracts that are much, much more powerful. And you have a lot of people experimenting with that. So you have people building games that are much more elaborate than what you could have on blockchain. Today on blockchain, most of the games you have will revolve around the logic of the game will be off-chain and asset management is on-chain. So executing the game is done on a single server, but the assets are moved through a blockchain. Now with this kind of thing, you can run the gameplay on-chain. The second thing is you can have neural networks on-chain, or better said, you can have verifiable neural network execution. Think about it. If you're running a neural network for your company, your users are able to use the output, but they have to trust you, or your partners have to trust you, or you have to give them the model and execute it themselves, which is very expensive and cumbersome. Now you're able to run a neural network or a machine learning model on your machine and prove that you run that machine learning model to anyone who wants to use the output. And it's much easier for them to use this output than it is for you to run the model. So this brings a lot of interesting capacity in smart contracts, but also outside of the blockchain world. So this brings new capacity to smart contracts on the blockchain. You can also use this new complexity to do much more complex stuff. And we have people working with world simulation, so building autonomous world. Actually, you guys are probably familiar with Liu Cixin's books, which are called, the free body problem, like the free body problem series. You have some people building autonomous worlds like Trisolaris, and where the goal of the game, which is executed on chain, is for all of the players to collaborate in order to not crash into the sun, which is kind of fun. Another really interesting feature of Starknet, and I'm not going to get too much into that because it's very blockchain centric, is something we call account abstraction. So if you've used the blockchain in the past, you know that you have to use private keys. This is fine, but it's not ideal. It's really hard to use for most people. And by building a new blockchain like Starknet, we're going to benefit from hindsight of a lot of blockchains being developed over the past 10 years. And one thing we noticed is that there's something better you can do, and it is dissociating the signer from the account. And that's what we've implemented. So it allows to do applications that have a much better UX than traditional blockchain networks. So you have people who are doing stuff like signing with your iPhone and basically using the same patterns and tool that your users are used to using. The third interesting thing you can do on Starknet is something we call trustless bridging. Since the Starknet networks, when it operates, it generates a proof of what it does. The underlying blockchain, in our case Ethereum, is really able to understand and audit what happened on Starknet. It doesn't look into the detail, it just knows that things happen correctly mathematically. And this makes the network Starknet inherently more secure than other networks that use game theory. It's the only instance where you have two networks natively talking with each other. And so you're able to really leverage on layer 2 things that are happening on layer 1. Starknet is not so much another network from Ethereum as much as it is an extension to it. So you're able to leverage things that happen on Ethereum in a very easy to use and cheap manner. All right, the fourth thing I want to talk about is storage proof, but I'm not going to get too much into this because it's very blockchain centric and probably not as interesting for you as other stuff. The last thing I want to mention, because it's kind of fun, is what we call fractal scaling. Fractal scaling is essentially this. You remember that I explained that you can run a computation and generate a proof for it, then send the proof to Bob, and then Bob will run a program to verify that proof. Well, what if the program that Bob runs is also provable? What if Bob runs a verifier that is written in Cairo and he can generate a proof that he verified your proof? Well, in that case, you get a reduction from you to Bob, right? But you also get a reduction from Bob to Charlie. Bob is able to verify your proof and generate a second proof that he did, and that second proof is even faster to verify than the proof that Bob received. And what is funny with that is that it can go into a lot of directions. That's why we call it fractal scaling. It can allow you to split a big proof into smaller proofs, right? So let's take a blockchain, for example. You want to prove block 0 to 100. Instead of proving all your blocks sequentially, you can prove block 1, block 2, block 3 in parallel, and then get all those proofs and generate a proof that you verified all of them. So this allows you to parallelize the processing of your proofs. It also allows you to delegate some of the work you're doing in your application outside the chain. So now if you want to have some logic on chain and some logic run on your server, you can run that logic on your server in a provable manner. You can still use the output in your blockchain smart contract. And what is funny with fractal scaling is that it really goes in a lot of direction. Another good, funny aspect is that you can have your users generate proofs on their laptop or on their device and submit the proof to the chain to be verified, allowing them to execute stuff on their side and use the output trustlessly on chain. So it really allows to push computation to the edge of the network and just use the network as a synchronization mechanism to verify proofs. All right, so that's what I wanted to talk to you about Starknet. I hope this made sense, and I hope this was useful. I'm adding here 2 links, one to a Cairo 1 tutorial that is written in that is very close to Rust, and one to our newsletter where we send about every 2 weeks news from the ecosystem, cool tutorials, and good learning resources. All right, I hope this answered some of the. I hope you learned something, and I'm happy to take questions now.
Okay, thank you, Mr. Henri Lieutaud. Dear audience, if you have any questions, please let us know. So let's start the Q&A session. Actually, like I just asked my coworker, since it's 4 p.m. in China and our TinTinLand students are still working. So on top of that, people have troubles with English. So most of them use plugins on YouTube to watch it. So a lot of people told us that they would watch the record later. So right now we have, as you mentioned, we have 126 students watching this currently. And yeah, most of them are through YouTube, and 17 people clicked like. But I'm pretty sure that they will have hundreds of people watching the recording the following couple of days. So yeah.
Well, look, if they want to ask questions in Chinese in the chat or on YouTube, and then I'll answer them, and then you translate them and I'll answer them. I'm happy to do that. Other than that, if you have more questions, happy to.
Yep. I saw the Brandon wrote something in the chat box.
Yep. So Brandon is asking, can you explain the differences between Starknet with other L2s like Optimism, Arbitrum in terms of dApp development, for example, for DeFi, for gaming and stuff like that? That's a great question. So I actually have some slides about this. Let me pull them up. Boom, boom. All right, let me share my screen. So this is a slightly longer presentation that I do sometimes, but I'm going to go back to that place. So, right, remember at the beginning of the presentation we talked about the legacy world versus the blockchain world, and the question is, how do you scale the blockchain world with currently? So up now, how do fraud-proof validity rollups work? And networks like Optimism or Arbitrum are what is called fraud-proofs network. The way they work is essentially like your bank. The way your bank works is not that they're running your accounts and they have no control. They're running your accounts, and every once in a while, the regulator will step in, take a look, and make sure that everything is correct. So maybe they do this every year, maybe they do this every few years. And if something is wrong, they penalize the bank, and things get back to normal. But this takes a lot of time and a lot of effort, and it doesn't always work. Optimistic rollup essentially work the same way. They have a central operator that runs the chain, and every once in a while, it will publish the list of everything it did on Ethereum, and anyone is able to take a look at, and this data is published, but the contracts are not executed. Anyone is able to take this data and re-execute it themselves. And if there is something wrong in the execution, say, hey, you cheated here, and then the operator gets penalized. The issue with so it's essentially like a bank, right? But instead of having one regulator who can step in and take a look at what is being done, anyone can step in and take a look at what is being done. And instead of having a time resolution of a few years, it's a time resolution of a week. So it is better than how it works in banking, but it still relies on game theory. It relies on the fact that somebody will have to step in and re-execute everything and make sure that the person on the other side didn't cheat. So that person who also steps in sometimes might have more incentive to take a bribe than to say, oh, something is wrong there. So that's the main difference, right? Fraud proofs rollup rely on game theory, and they work by hoping the sequencer, the operator, is honest, and hoping that somebody will look over his shoulder. Validity proofs are fundamentally different because the operator has to prove he did something wrong. I'm sorry, the operator has to prove he did things correctly. It's not that somebody has to prove he did something wrong. It is that he has to prove that he did things right. So they're inherently much more secure. So, you were talking about the impact for DeFi, for gaming. For DeFi specifically, validity optimistic rollups have a 7-day dispute window where anyone can say, hey, they're trying to steal money. Validity rollups don't have this thing. As soon as the proof hits mainnet, the output is usable because we know that it is valid. So there's a much tighter coupling between validity rollups and the underlying network than between optimistic rollups and their underlying network. Now, one thing that optimistic rollups have going for them is that they're using the same development environment than Ethereum, meaning that you can use Solidity, which is a smart contract language of Ethereum. You can use often the same tooling and everything. So they optimize for developer comfort. Validity rollups, in our case, since they have to use Cairo, means that the developers have to learn a new programming language, and they have to use different tooling. Now, though this tooling is quickly catching up and it's getting better every day, but it's still something that people need to learn how to use, and yeah, essentially that's the main difference between both, right? Validity rollups are more secure, but they're a bit harder to use for devs. Now, the good news for you who are watching is that you're into Rust, and Cairo is very similar to Rust. So for you, it's easier to learn how to do Cairo than to learn how to do Solidity. And the good news is you can build applications that are cheap and more secure than if you were learning Solidity and either deploying expensive applications on Ethereum or deploying less secure applications on optimistic rollups. I hope this answers the question. Let me know if it doesn't. And I see, Brandon, I see that there's a second question. Could you evaluate the advantages and disadvantages of Cairo and Move language? So I'm not familiar enough with Move make a meaningful comment here and to tell you Move versus Cairo as a pure programming language. One thing I will say two things. First of all, I think Move is its own thing. It's a blockchain language. And so Move is a language that makes sense in the context of a blockchain. Cairo is a general purpose programming language, meaning you can program anything in Cairo. It doesn't have to be a smart contract. And the second thing is Cairo being a general purpose programming language, we figured, okay, why don't we model after one of those general purpose programming language, and why don't we model it after Rust? And so we modeled, and so Cairo looks a lot like Rust. It has traits, implementations, it has, the syntax looks like Rust. Some things are a bit different, but most of it is very similar to what people are used to using with Rust. So it has that going for it. And then I think the biggest difference between Move and Cairo is the fundamental core one, which is that Cairo is provable. When you execute a Cairo program, you can generate a proof that you did, and you can leverage that asymmetry to build really interesting stuff, which you can't with Move. Maybe I'll give a broader example that I think might resonate with some of you. China has a very ambitious space program to send rockets to faraway planets. Now, sending those kind of rockets requires you to have very powerful computers in order to calculate the trajectory of your rocket and how much fuel is going to be used at each step. This is a very critical part of sending your rocket, because if your program doesn't execute correctly, then you will consume fuel at the wrong time and your rocket may crash. So it is very, very sensitive calculation. It's not a calculation that you can easily delegate to somebody else, because if you delegate it to another country, for example, let's say you don't have a supercalculator to execute that calculation and you delegate it to another country, you're essentially giving power to that other country to crash your rocket. Because if they don't execute the calculation correctly, if they change just one bit somewhere during the calculation, then the result will be entirely different and your rocket will crash. If your program, your calculation program, and I'm making this up, is written in Move, then if that other person executes it, you have nothing to use but the output and their word. You have to trust them that they executed the program correctly. Now, if your calculation, your program is provable and is written in Cairo, you can actually delegate it to somebody else. They will run the calculation and send you back the proof. And then you will be sure, 100% sure, that the program you wrote was executed correctly by that person. That's very powerful. It allows you to delegate essential computation to people you don't necessarily want to trust, but who have the power to execute that computation. And that's the main difference between Cairo and all other programming language. It is provable. I hope this makes sense. So Catherine is asking, I want to learn Cairo. Could you recommend some materials to me or some project cases? Of course, I'll be happy to. I'm going to direct you to 2 tutorials that I like. So let me share my screen again. So I think, just a second, trying to find the proper tab to share. Where is it? Okay, let's say it's this one. So, the first one is called Starklings, and it might sound familiar because it's modeled after Rustlings, and it's a GitHub repo. You download this, and it's a set of exercises that will make you write Cairo code. It's not smart contracts, it's pure Cairo code. I'm going to share the link also in the chat. And with this, you should understand the syntax of Cairo, how you use it, and what kind of stuff you can do with it. Associated with this is the Cairo book. The Cairo book is a big resource that will tell you everything you need to know about Cairo, the smart contract language. I mean, the programming language and the smart contract language. Now, if you want to learn more about Starknet, the network, I suggest this resource, which is the Starknet book. The Starknet book is basically explaining everything you need to know about Starknet, so that you understand, how the network works, what are its ins and outs, and what are the cool stuff that are being built on top of it. Of course, if you start developing, you'll also want to go to the documentation of Starknet. I'm going to share it here. And if you want to start using Starknet smart contract, we came up with this tutorial, which is called Starknet Cairo 101. And this tutorial will let you interact with smart contracts on Starknet. You won't have to write code for this one, just interact with it and figure out what to do with the network. It's a nice resource, it's a nice step, it's a nice first step into the ecosystem. So I hope these resources will help you. Let me know if you have any question. I see that Brendan is asking, does Starknet use ETH to pay gas fees? The short answer is yes. Starknet uses ETH currently to pay for gas. The long answer is it won't always be the case. Starknet is currently being developed, and part of its roadmap is introducing a Stark token that will be used for two purposes. One is for paying for gas fees to pay the operators of the network. And the second is the Stark token will also be used for operators to stake in order to decentralize the network and make sure that anyone in the world can run their own operator of Starknet, provided they have committed enough capital to secure the network. So short answer, currently it uses ETH. Long answer, in the future it will use the Stark token, but longer answer-ish still is with account abstraction, you'll be able to abstract this away for your users. So you won't even have, if you want your users to not worry about gas fee, you can abstract this away. And if you want them to pay in ETH, you'll be able to do that too. So Faye is asking, I tried both Starknet mainnet and optimistic rollups, and it seems to me that the transaction cost on Starknet is higher and transaction confirmation takes much longer, the same as ZK Sync. Will ZK rollup catch up with OP rollup in transaction speed and transaction fee saving? That's a great question, Faye. Here, what you're referring to is the fact that both stacks, either Optimistics and ZK Rollup, have different degrees of maturity. The Optimistic stack is more mature than the ZK Rollup stack. They started working earlier, and there were the theory for how they work is a bit older than the theory of how ZK Rollup works. So currently, I would say that ZK Rollups are in the same stage as optimistic rollups were in late 2020 or early 2021. If you were using those network at that time, optimistic was cheaper than Optimism was cheaper than Ethereum, but it was still pretty expensive. It was not as cheap as it is today. And ZK rollups are very much in the same spot right now. They're less expensive than Ethereum, but still a bit expensive. Like a transaction will cost you 10 to 50 cents, and transaction confirmation time can take a long time. Now, I'll say this: 3 weeks ago now, we shipped a very big new upgrade on Starknet, and now transaction confirmation is much faster in the orders of, it used to be in, tens of seconds or minutes even. Now it's in seconds. It's much, much faster. So do take a look again. The transactions are much easier and the experience is much smoother. As far as transaction cost goes, right now, most of the transaction cost goes to security for Starknet. For a problem that is called the data availability problem. I'm not going to get into that. What I want to underline is that we're coming up with a new design that will be shipped by the end of the year. We hope to ship it somewhere in October that will allow our developers to have very, very cheap transactions in the order of under a cent. So this is something we're working on, and in the next 6 months, you should see meaningful improvement on that front. I hope this answers the question.
Okay, I guess no more questions for now. Thank you, Mr. Henri. Thank you, everybody. If you have any other questions, please let me know, and I will forward to Henri in the future. So I think we can call it a day and see you around. Bye.
See you. Thank you a lot, and looking forward to meeting all of you somewhere online. And don't hesitate if you have any question on building stuff on Starknet and Cairo.
Oui, merci. À la prochaine.
Au revoir.
Au revoir.